Um, so, to find if a table is proportional, the easiest way is to find the constant proportionality. So let's take a look at the first one. So remember, to find the constant proportionality, we're going to use k equals y for x, right? To find this number right here, we're going to simply, and if this is my x and y, my x and y, x and y, x and y. So let's do the first one. I'm going to take one of these values, 2, 4, 3, 9, 4, 16. So let's pick 2, 4. If I pick 2, 4, I'm going to get k equals the y value 4 divided by 2. And the constant proportionality is 2. So I can come back here and write times 2, times 2, times 2. This is true. This is not true because 3 times 2 is not 9. And 4 times 2 is not 16. So is this a proportional table? No. The second one, again, pick 1, 2, 6, 3, 9, 4, 12. Pick one of them. It doesn't matter. Let's pick 4 and 12. If I pick 4 and 12, I'm going to do 12 divided by 4, which gives me 3. So this is times 3, times 3, times 3, times 3. That's true, that's true, that's true. And 0 times 3 is 0. So that's true. So is this a proportional table? Yes, because notice that the constant proportionality worked for every pair. This one, k equals, and let's pick, I don't know, let's pick this one. 3 over 3, which means constant proportionality is 1. So I can come back here and say 0 times 1 is 12, times 1, times 1, times 1. But let's confirm. That's not true. That's not true. 2 times 1 is not 6. 3 times 1 is 3. 4 times 1 is 0. No. So is this a proportional table? No. Last one. K equals, so let's pick a pair. Let's pick 3 and 15. So we get 15 over 3. So it means that this is times 5. So the constant proportionality is times 5, or the unit rate is times 5. It's 5. So it would be 0 times 5, times 5, times 5, times 5. True here, not true here. 2 times 5 is not 12, 0 times 5 is not 6, and 4 times 5 is definitely not 18. So this is not a proportional table. That's how you check. So here, I would create a table. One of these 4 equations matches this scenario here where he walked 1 mile in 15 minutes. So, notice how your equation is set. Your equation is set where it says the distance that you travel. If you want to find the distance that you travel, you have to do something. You have to you gotta for example, in letter A, you have to put the time and add 14. You got the time, subtract 14, and D1 says multiply the time by 15, and the last one says multiply the time that you walk by 1 over 15. So let's put it over here. So this is the time, 15 minutes. This is the distance. Let's start with a statement that was given to us. Time, 15 minutes. Distance, 1 mile. So, how do I get 15 to become 1 mile? Well, if you want to find a constant proportionality there, y equals k over x, right? Y, so this is x and this is y. You would go 1 over 15. Sorry, yeah. And then that tells you that to go from x to y to find the distance, you would have to multiply by 1 over 15. Let's see if that works. If I multiply 15 times 1 over 15, it's actually 15 times 1 is 15. At the bottom is 1 times 15, which is 15. What's 15 over 15? 1. So that works. This relationship actually works. So the constant proportionality is 1 over 15. So to get to the equation, once you have that, right, is how do I get, to find the distance, what did I do? What did I do here? I multiplied 1 over 15, right, times 2 times the time, right, 1 over 15. So I multiplied these two together. 1 over 15 times the number of minutes that you walk. So, but the number of minutes that I walk is going to be represented by the letter T. Because let's say you walk 30 miles, let's say you walk 40 miles, let's say you walk 50 miles. So, which all of these, what are we going to do with the x values? Times 1 over 15, times 1 over 15, and so forth and so forth. So we're multiplying everything times 1 over 15. So the formula that represents this statement is, hey, you want to find out how far you walked? Take the number of minutes that you walked, which is t, and multiply it by 1 over 15. So the only choice would be this one. 3, the table shows the weight of bananas to the number of bananas to the weight. So I have a relationship here, right? And in order to figure out what I multiplied this by, we need the constant proportionality. So take the one that you see here, and we're going to do k equals 1.6, right? Because the x value, y value, and divided by the x value. So 1.6 divided by 5, it's going to give us 0.32. So I can come over here and write times 0.32 times 0.32 times 0.32, and we can find the missing value. So the thirds, if I buy 3 bananas, 3 times 0.32, it's going to give us 0.96. What if I buy 12 bananas? 12 times 0.32, that's going to give us 3.84. So first question was the constant proportionality, 0.32. Write an equation to represent the table. So let's write the equation. So here, y, that represents the weight, right? This represents the weight. If I want to find the weight of the bananas that I bought, all I got to do is multiply 0.32 by who? By the values here, the number of bananas, 1 banana, 2 bananas, and they, in this case, are represented by the letter x. This is the formula that you use to find the weight of however many bananas you're buying, 10 bananas, 15 bananas. All you got to do is multiply by 0.2. Write a statement that explains the unit rate. So the unit rate is, so I'm going to add a line here. Right, makes it easier for me to see. So if I buy 1 single banana, so 1 banana, here's my unit rate. 1 banana weighs how much? Well, if I have 1 banana, what am I going to do to it? I'm going to multiply by 0.32. Which is going to give me 0.3. So for every banana, or 1 banana weighs 0.32 ounces. 0.32 pounds, sorry. Really? Okay. 1 banana weighs 0.32 pounds. Seems heavy. Strawberry cost $3 per pound. All right, so if you want to, so it really doesn't matter how you set this up. If you create a table, you can write strawberries, so pounds of strawberries, and you can write the cost. And what can we start with? We can say that if I buy 3 pounds, sorry, if I buy 1 pound, it's going to cost me $3. That's what I have. One, the question is, how many pounds of strawberries can you buy for $1? So what if I have $1 and I'll change colors? How many pounds of strawberries can I buy? Well, we need the what do you call the unit rate, right? So how many pounds of strawberries can you buy for $11? Well, so we're missing this guy over here and this guy, right? We need to know how many pounds. So let's find the constant proportionality. K equals y over x, right? So how did the 1 become a 3? What did I multiply 1 to become 3? So this one's going to be easy because the cost is 3, the number of pounds is 1, and the constant proportionality is 3. So it's times 3, times 3, times 3. 1 times 3 is 3 works, but now we're looking for something times 3 equals 1. So how do we find our mystery number? Well, to find our mystery number, we're going to divide 1 by 3, right? Or multiply 1, which is rather what I want you to think of. What is the reciprocal of 3? So over here, actually, so it's 1 times 3. So if you're going this way, you're multiplying by 3. So if you're going this way, you're going to multiply by 3. If you're going that way, are we multiplying by 3? You're going to say divide by 3, but I'd rather you think of it as multiply by the reciprocal of 3, which is 1/3. So I'm going to get rid of this guy here. Get rid of this guy, because that's not the direction we're going to go. We're going to go this way. So 1 times 1/3. So 1 times 1/3 is 1/3. So 1/3 of a pound I can get for $1. What if I have $11? How many pounds of banana? Well, again, times 1/3. So if I multiply 11 times 1/3, I get 11/3, which we can change to a mixed number. 3 goes to 11 3 times, and 2 left over. So I can buy 3 2/3 pounds of banana. That's the way that I would like you to do it. What is this? Oh, so that's from the previous question. Let's do 5. Same thing. You can create a table if you like. So we have water and what is this? Powder. No, tablespoons. Powder. Lemonade powder. So I'm just going to write powder. So it says that if I get 6 cups of water, I need 8 tablespoons of lemonade. So that's the relationship that's given to me. How many tablespoons of powder per cup of water? So if I have 1 cup of water, how many tablespoons of powder? That's one question. And how many cups of water per tablespoon? What? Hang on a second. How many tablespoons of powder per cup of water is that? So the first question is saying how many tablespoons of powder. So if this was a 1, how much water would I have? And the second one says how many cups of water per tablespoon of powder. Okay, how many tablespoons of powder per cup of water? And how many cups of water per tablespoon? How many cups of water? Okay, so I'm reading this incorrectly. Hang on a second. How many tablespoons of powder per cup of water? So if I have 1 cup of water, how many tablespoons of powder? Good. Second one, how many cups of water for 1 tablespoon of water? So I need to find this number over here. I need to find this number here and this number here. What? And in order to find that number, we need our constant proportionality. So let's look at our first. Right, gotta look here to find a constant proportionality. So k equals, this is x and this is y. We're going to do 8/6. If we simplify that, we get 4/3. And I'm going to leave it at 4/3. Okay? So 6 times 4/3, right? So because we're going this way. Is it 8? Let's just prove it. Put this over 1. 6 times 4 is 24. 1 times 3 is 3. And that gives me 8. So that's true. So 6 times 4/3 is 8. So the second one here, I'm going to multiply that by 4/3. And 1 times 4/3 is just 4/3. So if I have 1 cup of water, how many tablespoons of powder do I need? I need 4/3. 4/3. All right, so if you can actually write 4/3 or 1 1/3 tablespoons, up to you. The one in the back, the last one here, it's something times 4/3 equals 1, but we're not. So again, if we're going this way, you're multiplying by 4/3. And if you're going the reverse way, do you multiply by 4/3? No, you're going to multiply by the reciprocal. What's the reciprocal of 4/3? It's 3/4. So to find out how many cups of water, I'm going to go 1 times, because I'm going this way, times 3/4. And 1 times 3/4 is just 3/4. So if I have 3/4, so if I have, 1 tablespoon of powder, I'm going to use 3/4 cup of water. Again, you can create another table. Up to you know what? Actually, let's not create a table for this one. So it says 6 square yards. I'm going to use a proportion. 6 square yards. I get 54 square feet. Yeah, maybe I should have. That's okay. So on top here, this is going to be square yards. This is going to be square feet. We have options. So what happens when I have 9 square yards? What happens when I have 9 square yards? How many square feet in here? What can I do here? I can put an X and cross multiply. You can see if there's any relationship. So what times 6 equals 9? Maybe it's not so obvious, but it'd be times, multiply times 1.5. If I do that, I would multiply the bottom by 1.5 to get the answer. So that's one way of solving this. I can cross multiply. If I cross multiply, I'm going to get 6 times x. And then I'm going to multiply 9 times 54, which gives me 486. Divide both sides by 6. And I get that x equals 81. Right, so this would be 81. So you can do it that way. Or how about if I did this way? If I look this way. 6 times what's 54? Well, it's times 9. So from here to here would also be times 9. And 9 times 9 is 81. That's one that people sometimes forget about, that relationship, right? So we can go, we can set up a portion, we can side to side for a relationship, we can go up and down for a relationship, okay? This one, if you want to create a table, you can. Oh, they asked for the constant proportionality. I apologize. So what's the constant proportionality here? So I want to create a table, okay? And this one is square yards. This one is square feet. So this is 6. I get 54. And then they're asking us what happens if you have 9 square yards. How many square feet will? So we're looking for constant proportionality. So we're missing this number. 6 times something is 54. Well, obviously we know that it's 9. So the bottom here would be 9, and 9 times 9 is 81. So the constant proportionality, K, equals 9. This one, let's keep the same time. Let's keep it to the same. Let's create a table. What do we have here? Ducks. I'm using ducks and turtles. And we have a relationship that says that every time there's 5 ducks, there's 4 turtles. Create a table to show the number of turtles if there are 25 ducks. So what happens when there's 25 ducks? How many turtles will I have? Well, we need a constant proportionality, right? Because I don't know 5 times something is 4, and I'm going to use that same number to get the number of turtles. We need the constant proportionality. So k equals y over x. Right, so let's make this x and y. How did the 5 become a 4? Because I multiplied by something. So it's going to be 4 over 5. And you can leave it as a fraction. You can leave it as a decimal. This one becomes a nice decimal, 0.8. I mean, I just don't like that sometimes when it's repeating decimal. We're not going to use a repeating. I need you to use the fraction version of it. But this one is okay. So either or. So let's use 4 over 5. So 5 times 4 over 5 is 4. That's the thing. So this one, I'm going to multiply that by 4 over 5 again. So 25 times 4 over 5 is just 20. Okay, you can use a calculator or you can multiply mentally. 25 times 4 is 100. 1 times 5 is 5. And what's 100 divided by 5 is the same thing as 20 there. So what was the constant proportionality? 4/5. If you want to add one more line and put a 1 over here, so that means that if I had 1 duck and I multiplied that by 4 over 5, I would get 4/5 of a duck, not a full duck. Okay. Now this one, that gave you some trouble today. So let's go to recipe 1, recipe 2, recipe 3. Which recipes will taste the same, which one will taste different, explain how you know, find the constant proportionality, create a table, blah, blah, blah. So the first one, OJ and pineapple. OJ and pineapple. OJ and pineapple. So let's create a table. And the first one is 4 cups of OJ, 6 cups of pineapple. The second one is 6 and 9. The last one is 9 and 12. Well, right? So let's find the constant proportionality and the unit rate. So let me write a 1, a 1, a 1. So if I have 1 cup of OJ, how many cups of pineapple do I need? Well, first we need to find the constant proportionality. So let's do that for this one. We're going to do x and y, x and y, x and y. So if OJ is x and pineapple is a y, we're going to do 6 over 4. And if you simplify that, you get 3 over 2. So that's the constant proportionality. So 3 over 2 or 1 and a half. So 4 times 1 and a half is 6. Yes, it is. So now I can use that for the unit rate. So what happens if I have 1 cup of OJ? Well, I'm going to multiply that one by 1 and a half. And that means I need 1 and a half cups of pineapple. So that's my unit rate here. Second one, let's do the constant proportionality. It's going to be 9 over 6. And divide by 3, it's going to be 3 over 2. Or 1 and a half. So 6 times 1.5 is 9, which means this one I'm going to multiply that by 1.5, and 1 times 1.5 is 1.5. Notice that the constant proportionality here and here is the same. So the second recipe also says that if I have 1 cup of OJ, I'm going to need 1.5 cups of pineapple. So the first and the second are the same. Let's look at the third one. We're going to do k equals 12 over 9. Let's divide this by 3, I get 4, and let's divide 9 by 3, I get 3. So this one is times 1 1/3 or just 4/3. And let's change that to 1 1/3. So 9 times 1 1/3 is 12. So 1 times 1 1/3 is 1 1/3. So for the last one, if I use 1 cup of OJ, I'm going to need 1 1/3 cups of pineapple. So notice that this amount is different than the previous two. So this is the one that's different. Okay, so that's this. Notice how having the unit rate, right? Having the unit rate makes comparisons so much easier. Okay, come in handy, right? 9. All right, so we gotta let's see, complete the table, explain, blah blah blah. Okay, what's the constant proportionality? Well, let's find it. X and y. K equals, let's use 2 and 6, so 6 divided by 2, which is 3. There's no constant proportionality. So times 3, times 3, times 3, times 3. And if you wanted to, we're going to add another line here with a 1. Okay? Let's add one more, because that's going to be our unit rate. So maybe it's easier to see it that way. 2 times 3 is 6, check. 3 times 3 is 9, check. 10 times 3 is 30. Right? And then here, instead of multiplying by 3, what are we going to multiply? Well, because we're going the other way. So what's the reciprocal of 3? The reciprocal of 3 is 1/3. So it's going to be 45 times 1/3, which is 15. I'm going to put a 15 here. And if you go back to the right, from left to right, 15 times 3 is 45. So this is the correct answer. So what happens when you have 1 cup of rice? Well, times 3. I'm going to need how many people? 3 people. What's the constant proportionality? K equals 3. State the unit rate. Well, the unit rate says that 1 cup of rice feeds 3 people. Write the equation to represent the table. Well, so the question here is, you're always going to talk about y, okay, because that's the result that I need to figure. So if I want to know how many people I can feed, so if I let's call it P, the number of people I can feed, I'm going to need to multiply what? What am I multiplying by? I'm multiplying 3 times the number of cups of rice. So 3 times the cups of rice. So if I want to, I don't know, if I had 12 cups of rice, how many people can I feed? So if I had 12 cups of rice, how many people can I invite over? It's 12 cups of rice. Well, I'm going to take this 12 and put it over here. So I would go 3 times 12, and I can feed 36 people. What if I had, I don't know, 20 cups of rice? Well, if I had 20 cups of rice, 20 cups of rice, I would go 3 times 20. And that gives me 60 people. So if if you want to find the number of people that you can feed, all you gotta do is multiply the cups of rice that you're cooking times 3. Okay. Or so the equation is that, or if you want to write in terms of x, it's y equals 3x. To get this number here in the y column, I gotta multiply everybody in the x column by what? By 3. 10. Same thing. Find the constant proportionality. Well, so let's take x and y. So x times something gives me 3. Let's find that something. I'm going to use that something over and over again, but we have to find the ratio between y and x. So if I have 6 spring rolls, I can feed 3 people. So the constant proportionality is going to be the y value over x. So 3 over 6. K equals a half, or if you want to write it 0.5, that's okay. So it's always all times a half, times a half, times a half, times a half. 30 times a half is 15. 40 times a half is 20. Half of something is 28. What was that number? 56. So 56 spring rolls, I feed 28 people, and let's go for the unit rate. What if I have 1 spring roll? How many people can I feed? Well, 1 times a half would be half of a person. I know it doesn't make sense. Can't have half of a person, but that's the unit rate in terms of the spring rolls when you have 1 spring roll. We could have done this backwards, where I could say, what happens if I have 1 person? How many spring rolls do I need? Okay, we'll get to that in some of the later questions. So, what's the constant proportionality? Half. Say the unit rate in words: 1 spring roll for every half of a person, because we did it this way. We could have switched the columns. Write an equation to represent the table. So if I want to find, and we always start with the y column and the right, so the number of people, if I want to know how many people I can bring to the table to feed the spring rolls, all I got to do, what did I do over and over? I multiply half times what? Times the number of spring rolls, and let's call it r. So you either wrote the equation like this, so if you want to use y and x, to find y, to find this number, the missing number in the y column, you did half times whatever x was. This is more specific, and this is the generic one. Okay. 11. Oh boy. 12. Oh my god. 11. Complete the table, blah, 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 and all that stuff. All right, so same questions as the prior two. Times something, times something, times something, times something. So what's the constant proportionality? If this is x and this is y, k equals, let's use the pair 8, 10. We're going to go 10 over 8, or 5 over 4. So you can leave it as a fraction, 5 over 4, or 1.25, or 1 1/4. All these three means the same exact thing. Okay. So over here, I'm just going to write 5 over 4. 5 over 4 times 5 over 4 times 5 over 4 times, well, I'm going to leave that one blank. So the second one, what happens when I have 8 tablespoons of honey? How many cups of flour do I need? Well, 20 times 5 over 4. And that's going to give us 25. 13 times 5 over 4. I have no idea what that is. So let's do 13 times 5, enter, divided by 4. We're going to need 16.25, 16 and a quarter cups of flour. But this one, it's something times 5 over 4 is 20, but we're not going this direction, right? To get to x, we have y and we have to get back to x. So we're not going to multiply by 5 over 4, but the reciprocal rather of 5 over 4, which is 4 over 5. So 20 times 4, enter, divided by 5, and that's going to give us 16. Right, because we're going this way, don't forget. Yeah, so what's the constant proportionality? Well, if we're going this way, the constant proportionality is 5 over 4, right? If we're going from honey to flour. What's the constant proportionality when I went the other way, from flour to honey? Well, it was not times 5 or 4, it was actually times 4/5. So there's two constant proportionalities, right, depending on which way you look at it. Write an equation to represent the table. So here's my first equation. To find this, to find y, how did I get, what did I do to the x to get the y? What did I do to the 8, to the 20, to the 13, to get 10, 25, 16.25? I multiplied all of them by 5 over 4. I multiplied 5 over 4 times all the x values. Okay, we're going to talk about the reverse in the next two problems, or I'm going to talk about it. All right. Okay. So this one is going to be like double the work. Yay. Sam walks at a constant rate of 12 miles in 80 hours. So let me create a table. All right, table 1 and table 2. Table 1, I'm going to write miles over here. That's going to be my x, and minutes over here. So 12 miles, 80 minutes. 1 mile, how long does it take? So we need to find the constant proportionality, right? Going from x to y. So times something, times something. Let's find the constant proportionality. So we're going to do k, 80 divided by 12, which is going to equal 6.66666. So I'd rather write that as 6 2/3. So this is actually 6 2/3, which is 6 2/3. So 1 mile, how long does it take for him to walk 1 mile? It's 6 2/3 of a minute. Everybody okay with that? So keeping that, right? So the constant proportionality going that way, right, from miles to minutes in terms of minutes, so it would be 6 2/3. Now let me draw a different table. Draw a different table. In this table, x and y are going to be different. X is going to be minutes, and y is going to be miles. So using that same statement here, it took 80 minutes to go how many miles? 12 miles. So in 1 minute, how much can you travel? So notice that the perspective is a little bit different. How do I find the constant proportionality here? Same way, but it's going to be reversed. It's going to be 12 divided by 80. So if we simplify 12 over 80, you actually get 3 over 20. Right, so the constant proportionality in this scenario is 3 over 20. Okay, hopefully you can see that. So 3 over 20. So I'm multiplying this by 3 over 20, which gives me 3 over 20. So let me write 2. So there's two constant proportionalities, depending on how you set up the table. One is 6 2/3, and the other one is 3 over 20. Okay. Let me write a statement here for this guy. 1 mile for every 6 2/3 minutes. Let me write a statement here for this one on the right side. 1 minute for every 3/20th of a mile. Okay, they both mean the same thing, but one's in terms of miles and the other one, in terms of minutes, the other one in terms of miles. Okay. So the next question says, what if you walk 7.5 miles? Well, if you walk 7.5 miles, which table are we going to? We're going to use this table. So continuing that table at the bottom here, so imagine I extended it. And I put 7.5 miles in here. What am I going to multiply that? So if I walk 7.7 miles, 7.5 miles. I multiply that by 6 and 2/3, and I should get the number of minutes that it took me to walk that. So we're going to multiply 7.5 times 6 and 2/3. And that's going to give me that it took me 50 minutes. Okay, so a little different of a question, yeah? Depending on who you put in the X and the Y. So this one is going to be the same question except a little different. So let's create the first table. In the first table, we're going to put, I don't know, let's put hours over here and the money that you earn. So it says here that if you work 4 hours, you earn 60 bucks. Let me add the 1 here because that's what I need to find. So 4 times something is 60, and we're going to use that same because it's constant proportionality for the 1. So to find the constant proportionality, we're going to take 4 and 60, and we're going to, sorry, X and Y, and we're going to divide 60 over 4, which gives you 15. And that makes complete sense. 4 hours, you get 15 bucks per hour, you get 16 total. If I work 1 hour, I get paid 15 bucks, and I take home $15. Okay, so that's when you have hours as your X and Y is your dollars. What if I switch them? If I switch them and make the X the money that you earn and the Y the hours. Well, think about it. Now it says that I earned 60 bucks in how many hours? 4 hours. So what if I earned $1, $1? How many hours did I work? Well, that's kind of weird, but that's what this is going to be talking about. So let's find a constant proportionality. K equals, I mean, this time we're not doing 60 by 4, we're going to do 4 over 60, which is 1 over 15. So, I think I say so too many times. 60 times 1 over 15, is that equal to 4? Yes, it is. 1 times 1 over 15, it's equal to 1 over 15. I was about to say so again. So what are the two constant proportionality? One is 15, and the other one, hint, is the reciprocal. And what's the reciprocal 15? 1 over 15. So this you already knew. Okay. Let's write two different statements. I know it didn't ask for it, but let's write two different statements. So statement one, I'm going to write 1 hour of work. For every 1 hour, you earn $15. The other one says for every $1, that you earn, you work for 1/15 of an hour. Not an hour, not a complete hour, 1/15 of an hour. Okay, so see how the statements are a little bit different. Okay, write two different equations. Okay, so let's use the first table. So the first table, y, the total, is the amount that I earn. So think about y, the amount that I'm going to take home, right? The amount that I'm going to earn, which is represented by the letter y. How do I calculate that? Well, I'm going to simply, it's 15. I'm going to multiply 15 times what? The number of hours that I work, which you can put as h or x. So this is the first table. The second table says to find the total number of hours that I'm going to work. Right? I'm going to multiply 1 over 15 times however much money I make. And what do we use for money? Let's use M for money. So if you want to know how many hours you need to work, okay, multiply the amount of money that you're going to take home times 1 over 15. So if you want to take, I don't know, 150 bucks home, how many hours do you need? Well, you would use this. Here, if you want to find how much money you're going to take home, then multiply the number of hours that you work times 15. Little backwards, right? But that's your next step that you have to. Is that it? Really? Okay, that wasn't that bad.